Hello and welcome everyone. I just wanted to explain the recent code forces round 846 division to problem B. The problem name is GCD-Partition here. And in this problem, what you're going to have to do is, the problem statement explains that you're going to be given an array of n length and you can you, and you're allowed to do some subsegments or subdivisions inside the array. And after that, after you make some subdivisions of the entire array, let's say this is the array, and you would want to do some subdivision, make some subsegments, you are allowed to do that. And after that, those subsegments, each and every one of those subsegments, you're gonna try to try to make the sum and make a new array B. So um, ultimately, the array B is going to be evaluated by the overall GCD of all those elements. So ultimately, what happens is you're going to try to calculate the GCD of the array B, and each and every element is going to consist some sum of those subsegments of the previous array A. So if I talk a little bit about the operation here, if let's say you pick k equal to 3, let's say for a random value k equal to 3, so the b array is going to be generated by this one of the ways that the b array can be generated by from A is like this. You create three segments, three teams, three groups, each consisting of subsegments like that. Okay, 7 7 7 7 and 7 7. Okay, we've got three groups here, and what you're going to do is the first element is going to be the sum of these two, so 7 7, 14, similarly 14 and 14 here, and the third one would also be 14. And finally, what you're going to have to do is just try to run the GCD operation of the whole array B, and that answer is going to be the final answer, and you are being told to try to maximize that value. Now, the question is, how are we gonna try to find out a value such that it gives the maximum possible result? So let's go to the root area of the problem where we're given we have to choose, like, think about it, we're gonna have to choose some efficient k, which is gonna give us an optimal result. Now also they've already told us one thing is that k should be greater than 1. K is not allowed to become equal to 1, because if k is equal to 1, then you know that the answer is going to be you know that the efficient answer would be the whole array itself. You could consider the whole array as a total, all of the subsegments. You could just sum all those and it just gives you the maximum value, but that's not the case here. K cannot be 1, so k should be greater than 1. Now if k should be greater than 1, what is the efficient k value that's going to give us the maximum possible result? How are you going to find out about that? Well, I'm going to make a claim now, and that will be k's value would always be equal to 2. Now, why I'm claiming that k should be always equal to 2, why it's always the best answer, why we're always going to get the maximum value, maximum answer, final answer if we choose k equal to 2. You see, the reason is that here the operation finally is going to be done, that's going to be done is the GCD operation. And if you recall it, GCD is the greatest common divisor, meaning, let's say we've got two numbers, let's say any two numbers, let's say A and B, and if I perform the GCD, what it's going to give? It's going to give me the maximum possible value that's going to be divisible by, let's say A and B are two numbers that I want to do some GCD operation. And if I do a GCD operation, it's going to give me the maximum possible value, which is, of course, less than or equal to A and B. Um, and that's going to be divisible by A and B, respectively. So, um, we know that it's going to be the maximum possible value that's going to be divisible by a and b, and of course it's going to be less than or equal to a and b. If a, let's say a is less than or equal to b, then the value, the GCD value will lie uh, from 1 till this smallest value, but it's going to be the maximum. So just think about it. If you do more partitions, would that make your result better? No, it will not, because if you make more partitions, you would see that you'll get less number of sum. So if you get less number of sum, and if you, uh, uh, what it means finally, you are applying the GCD operation on more partitions, having less number of sums, and finally it's going to give you a GCD value, which is going to be less than or equal to the smallest possible sum value. Let's say you get like what, five let's say you create five partitions, let's say consisting like some value like 2, 3, let's say 15 and 16. Okay, now if you perform a GCD operation of all of these, you will guarantee to get a GCD less than or equal to 2, because it's you're performing the GCD ultimately on the whole array. So making more number of partitions will not benefit us. It will not provide the optimal result. So what we're going to have to do is somehow make it make the array, make the partitions as small as possible, such that the sum of those partitions become much more greater, and thus giving us the maximum possible GCD result, which would be the optimal answer. And so, as we're not allowed to use k equal to 1, we're allowed to use k equal to 2, and that's exactly what we're going to choose. So, we're going to choose k equal to 2. Now, first of all, we're going to choose k equal to 2, but what is going to be the exact position that we're going to try to, divide the whole array? Now, that's the answer that we do not know, but we could do a sort of a linear brute force to find out which partition is right for us to captivate. And as you can see, let's take an example of this array. As we have already told you, the maximum of the optimal k would always be 2. So I'm gonna start with from this array. And yes, of course, I'm gonna take subdivision. So I'm gonna take all possible subdivision. That's gonna be the answer. So if I take this as one of the possible subdivisions, having this is my one group and this is the other group, I'm gonna take the sum and I'm gonna make the GCD, try to fill out what is the maximum value. Similarly, on the next step, I'm gonna take another two teams like here from here. And let's say this is my another group and this is my another group, so on and so forth. I'm gonna make subdivisions like that. I could easily do that brute forcefully in a linear fashion. It's gonna be within the time constraint to won't cause any problem. Um, and the efficient way to do that would be also to keep track of the prefix and the suffix part, prefix sum and the suffix sum part. That's going to help us to do that in a linear way. So the bottom line would be, we are given an array, initial array. We're going to try to find out all the possible two subdivisions, as we're going to take k equal to 2, which is the optimal, as we've already verified that. And we're going to try to find out what's going to be the answer for each and every subdivision. For each and every subdivision, we're going to we're going to try to GCD the prefix and the suffix of those two subdivision uh, respective subdivisions. And out of all those um, two k equal to 2 subdivisions, we're going to try to take the maximum GCD value. I it's to verify that. Let's take a look at the implementation part here. As you can see, we're taking the values here. We're taking and after taking the array here, we're taking the prefix and the suffix part. I hope you would know how to do that. And like this way, we're trying to predict the prefix and suffix part, and then after that, finally, for each and every uh, index, we're trying to figure out the possible two subdivisions that we can form. And we're going to calculate the prefix and the suffix, and then calculate the GCD. And out of all the GCDs, out of all the possible subdivisions, we're going to try to take the maximum one, and that's going to be the final answer. And that's how exactly what we're gonna how are we gonna how we're gonna solve this problem.